Okay, so in this video, I'm going to do exercise 142 and 143, which are more practice of doing the limits by combining some limits that we know with the limit rules for plus, minus, times, divide, and powers and stuff like that. So the first one, what is the limit as n goes to infinity of 1 plus 1 over n to the power 6? The way you should do this one, you should recognize 1 plus 1 over n in the middle here is inside the something to the power 6. And I can do the limit of 1 plus 1 over n. So I'm going to do this piece first. So the limit as n goes to infinity of 1 plus 1 over n. That's the stuff on the inside. By the sum rule, if you want, this is 1 plus the limit as n goes to infinity of 1 over n. Right? So 1 plus 1 over n has two parts. There's the part that's 1, 1, 1, 1, 1, 1. And then there's the other part that's 1 over n. So 1 over 1, 1 over 2, 1 over 3. The limit of just 1, right, of just the stuff with the 1, that is 1. The limit of the sequence that's always 1 is just 1. What is the limit of the sequence 1 over n? That's what we wrote down over here. And that limit is 0, 1 plus 0. And you can think of it logically or like intuitively. Why is the limit 0? You have 1 divided by a big number. As the number gets bigger and bigger, you're dividing by a really big number that's getting close to 0. The other way you could do it is you could just say by the building block, right? So by the result that says the limit as n goes to infinity of 1 over n to any power, that limit is always 0. That was a result we had earlier, so you could just say by that result, the limit is 0. In any case, the limit of this stuff in green over here is going to be 1. And so what is the whole limit that we're doing? By the power rule. So the original limit, the limit as n goes to infinity of 1 plus 1 over n to the power 6, it's going to be the limit of 1 plus 1 over n all to the power 6. And this is what is called the power rule for limits, right? So you can split it into two parts, the stuff inside to the power 6 and the part taking the things to the power 6, and you can do the limit of the little part first. And we did that already. That is 1 to the power 6. So, and 1 to the power 6 is 1. So the final answer is 1. So this one was pretty straightforward, kind of the most simple way you can think to break it up into stuff on the inside versus stuff on the outside. That works. If you want to think of 1 plus 1 over n as two parts, you can also think about it like that. And the limit of the 1 is 1. The limit of 1 over n is 0. Okay. Let's move on to 143. And this one they say is harder. Why is it harder? Because the sort of simple way to split it up like this, you could split it up into the top and the bottom. This will not work. And the reason is the limit of the top on its own, this is just the top. The limit as n goes to infinity of n is, of course, infinity, right? You could say by the result that says n to any power, the limit is infinity, or it's just, this is the most natural limit. The limit should be infinity. If n is getting bigger and bigger, what is n doing? Well, it's going to infinity. And what about the bottom? This is maybe less obvious. The square root of 1 plus n. This is the bottom. The bottom. This one is also going to infinity. And the reason you can do this one again in a number of ways, but you're taking the square root of a number that's getting bigger and bigger and bigger. And so the square root of the number is also getting bigger and bigger and bigger. So that's why the limit will be infinity. You could also kind of invoke the rule that says the limit as n goes to infinity of n to the power 1/2 is infinity. So we had a rule that says the limit as n to any power, that will go to infinity. And n to the 1/2 is the square root of n. That's very similar to what we have here. Very similar to what we have here. So you could take this and do a little bit of work to show that they have to be the same thing by doing the sum rule or something like that. But however you want to do it, the limit is going to be infinity. So we have a situation where if you try to split it up as the top and the top is going to infinity and the bottom is going to infinity. So this is one of those situations where it's type infinity over infinity, and type infinity over infinity means none of the rules apply. The rules don't tell you what to do when there's infinity over infinity. You have to simplify a bit first and then try to get to the right thing. And there's a number of things you could try. I would start with trying to divide the top and the bottom by something to see if I can make them not be infinity. And what would make them not be infinity? Let me see. Well, the bottom we said was like a square root of n. So why don't I try, and there's no guarantee it'll work, like you have to try it and see if it'll work. Let's try dividing the top and the bottom by the square root of n. Divide top and bottom by square root of n. Let's try that. So n divided by square root of 1 plus n is equal to n divided by square root of n divided by the square root of 1 plus n divided by the square root of n. So I divided the top and the bottom by square root of n. The top, n divided by square root of n, is just a square root of n. Right, n to the power 1 divided by n to the power 1/2 is n to the power 1/2. The bottom simplifies a bit, so this is where those algebra rules come in. Dividing square root of n into there, I would get the 1 becomes a 1 over n under the square root, and the n becomes a 1. So it's the square root of n divided by the square root of 1 over n plus 1. And now I think I'm in a good situation because the bottom, what is the limit of the bottom? The limit as n goes to infinity of the square root of 1 over n plus 1. This is very similar to what we did in the previous example, right? This is very much like 1 plus 1 over n to some power. In this case, it's 1 plus 1 over n to the power 1/2. It's the square root. So the limit is going to be 1 plus 0 to the power 1/2. Let me write it as 0 plus 1. So this limit is 0 plus 1, all with the square root. And this is similar to exercise 142. So you can do the limit of the inside stuff. The limit of 1 over n is 0. The limit of 1 is 1. You take the square root of everything by the power rule for limits. So the bottom is going to 1. The limit of the bottom is the square root of 1, which is just 1. What is the top doing? That was the bottom. This is the bottom. This is the sort of work for the bottom. Let's look at the top now. What is the top doing? The top is the square root of n, and that limit is infinity. We did that one already. The limit of n goes to infinity of square root of n is infinity. So the top is getting bigger and bigger and bigger, and the bottom is getting closer and closer to 1. So this is kind of a situation of infinity divided by 1. And infinity divided by 1, if the top is getting bigger and bigger, and we're dividing by a number that's very close to 1, the whole thing is going to infinity. So you could say, therefore, the limit as n goes to infinity of square root of n over square root of 1 over n plus 1 equals infinity. You could, if you want to say it in words, you could say since the top goes to infinity and the bottom goes to 1. Infinity divided by 1 equals infinity in some sense. Okay, they're not numbers, so don't say that. But if the top is going to infinity and the bottom is going to 1, the whole thing must be going to infinity. Okay, so that is exercise 142 and 143. There are more exercises in your homework and more posted on the course link as well that you can check out. Those ones have answers. Okay, I will stop the video there.